Now should be okay. Is it okay? Okay, that's fine. So good morning, hola to all. Yeah, I have to repeat, as Jacek, that yeah, I am not able to speak Spanish still, so I will lead my presentation in English. Good morning. Thank you for invitation. First of all, thanks to Amexico. That was mentioned already that I have a pleasure to have a webinar third time in a row. Hope not last time, maybe next year if it will be an invitation. Will be also my pleasure to have a new material. Thanks to Central National Norma Ortega also coordinating, joining with us, give us a chance to be present like a Monday. And present some technical issues related to paper, corrugated board and boxes. That was already so nice introduction of myself. So I have, I would say I can skip it and let's go just directly to the content, to the presentation, which has a title, Evaluation of Paper and Corrugated Board Runnability and Strength, based on available parameters. I have to add also that this material was created by me during a COVID time in 2021, which was much more webinars, as you for sure remember. So I mixed some slides from my existing materials, added some new, and decided to give this title. So this presentation is divided into two parts. The first part is about the paper parameters, how it looks like from a context of strength of corrugated board and boxes. And the second part is about the paper parameters versus runnability. How to get runnability in numbers, how to measure runnability, to describe runnability is good or bad based on paper parameters. So let's start our today journey following a topic. I cannot change the slide. Okay, that was already introduction. Yeah, quite often I'm starting my presentation with a sentence which I like very much, which was written by Michelangelo Buonarroti, that details create perfection, but perfection is not a detail anymore. More we know, better we are, more perfect, more efficient, etc. So I would say still very valuable sentence, good to have in mind, to remember that every small aspect is important, considering a total process, which every detail may create or support us on a way to the perfection. So in this presentation, I intend to share general information with all of you how to read and interpret parameters in terms of good paper and paper packaging runnability and strength. So on this slide, I put, I suppose, all or almost all parameters, paper parameters, and I was trying to divide. On the left side, paper parameters related to strength, to performance of packaging, and on the right side, the parameters which are telling us more or less about runnability. So let's start with the parameters. Corrugating process future. That is a slide from one of my presentation. Generally, my point of view is that looking on the data sheets, on the technical offers of paper producers, included our own, like Mondi, it's not so much information. Mostly we have a burst, a CT, something about the sizing, COP, sometimes Denison test, moisture level. Yeah, and that is more or less all, 4, 5, 6 parameters, which is, in my opinion, not enough. That should be much more. And the future, I would say, I'm sure about that. The future will, as always, future is coming with the new things and the new parameters. More complex technical data sheets should be present on the market, selling, presenting a paper to give more information. Yeah, that once more paper parameters. Let's talk about some of the parameters. SCT. SCT is yeah, most recognized, I would say, parameter, short compression test, and it's really perfect in case of expressing. Sorry, it's some audio still on the video. It's a very good parameter expressing a compression, a stiffness of paper in a very fast, quick way, etc. You see how it is going on the video. It's a 2 clamps, it's a gap 0.7 millimeters, and the machine is breaking a stiffness of paper, and the force which is doing that is as level of SCT. Very good methodology because it's covering, like I put on a slide in red digits, is covering a wide range of grammage substances from 100 up to 440. RCT, ring crash test, which is still quite popular, but unfortunately, considering what I told you about the SCT, also what I put here on the slide in the red digits, that this methodology is good, like a parameter expressing a stiffness, compression, but for a higher substances. The RCT correlate with the thickness of paper, so methodology is good for a papers, for a paper grammage in a range 200 up to 400. So, but on a way of lightweighting, more usable, more correct, more precise is SCT, not RCT, because a thinner paper creating a breaks on the edge of a paper ring, as you see on the photo on the bottom right side. So below 200 grams, RCT is not really good parameter if someone still using that. That is a very good graph, which I am always showing. On the left graph, you see the correlation between SCT and RCT. And as you see, it is a correlation, but from 200 grams and over. Yeah, that is a linear correlation. Below 200 gram or 186, because of a thickness of paper, that is lack of correlation between SCT and RCT. And because of that, it's again, I would say, repeat, better to use SCT in case of prediction. If someone is making any prediction of a corrugated board or boxes, that is better to use SCT, short compression test, not RCT. Tensile stiffness, that it's which I am always also repeating, the best parameter, I would say, if we want to describe how strong is a paper in case of how strong will be a box. Tensile stiffness, which is measured in machine direction and cross direction. You see how it is going on, a strip of paper, putting into the machine, 2 clamps, and paper is stretched off, yeah. So it's an elongation going on, and plus a force, which in a certain moment will make a break of this paper strip. So it's an elongation, like elasticity, and the force, which is also a force, a compression. So as you see this drawing on the right side, it's exactly parameter which is showing us very good in case of BCT of a box, where during pressing a box from one side is compressed, and from the opposite side is elongated. Yeah, tension is going on. So in this case, compression, tension, elasticity, and the force is tensile stiffness really the best, in my opinion, parameter covering every grammage and telling a bit more than SCT. Not only a pure compression, yeah, not pure static stiffness, but also is saying us about the dynamic of a paper, how high are dynamic parameters of a paper, not only a compression. Tensile stiffness, machine, and cross direction. Burst, yeah, still quite popular. Most probably all of you know how it looks like. Still very simple, good parameter indicating, I would say, content of fresh fibers. Yeah, also telling us about the dynamic, not about the static stiffness, but about the dynamic elasticity. So it's also still good parameter to estimate how strong will be a corrugated board and the boxes. Concora medium test, CMT, so-called CMT, Concora medium test, that we are just jumping from liners to a fluting. CMT, yeah, if some of you is doing that, okay, but I would say that is already, my opinion is not, it's a useless parameter. Yeah. First of all, methodology is coming from 50s, so it's more than 70 years ago. It's focused on an A flute, which is almost 5 millimeters high. Not so much A flute is produced globally, so it's not really parameter which is useful, which can be used somehow in any kind of estimation. In case of CMT, nowadays or last years started to be more and more popular a test which is called S-test. It's a new parameter, relatively new. Like in Mondi, we started to use this parameter 3 years ago, and already 2 years ago, the S-test became a part of our technical data sheet for recycled fluting. First of all, it's a very quick, as you see this short video which is going on, is similar machine instrument like for SCT, because it's also 2 clamps, 0.7 millimeter gap, and paper strip is in between 2 clamps, which are getting closer to each other when they start breaking a stiffness. Only, as you see very well just now, when a paper strip is tested, it is in a shape of an S. Because of that, this parameter is called S-test. It's a very good correlation with the CMT, not with the total CMT. If some of you is closer to CMT, most probably know that making a CMT test to crush, to press a flute, which is created on a Concora, that is a 3 peaks of performance, 3 times plateau, so-called, during a CMT test. So as you see on the bottom graph, that is a correlation between S-test and the CMT first plateau, this one. That is a very good linear correlation of S-test with the first plateau, first peak of CMT. So as I told, much faster than CMT, because CMT you have to heat up Concora to create a flute, to put a cello tape on a formed flute, to keep a shape of a flute, then to put under a press and squeeze it, press it to get a result. In case of SCT, like SCT, just a strip of paper into the machine, and immediately you are getting a level of S-test. Yeah, so normally considering a performance packaging, parameters of board and boxes, we are touching mostly the parameters you see: ECT, FCT, flat crash test, box compression, bending stiffness, not always, but good if it is mentioned, burst, and less PET, puncture energy test. Shortly, what is coming from? So ECT, the ECT of corrugated board, edge-device crash test, depends how strong, how high is the ECT, depends of the paper parameters which you see on the right side, which we discussed, which I described, SCT, short compression test. ECT correlate with the SCT, or SCT correlate with the ECT. Looking on the middle, bending stiffness of corrugated board, geometric bending stiffness, MD and CD, machine direction, cross direction, depends of level of tensile stiffness, MD and CD. as I was trying on some previous slide to also to describe this tensile stiffness, how complex this parameter is, and that parameter fully corresponding correlate with the bending stiffness of corrugated board. And the box compression test, BCT, yeah, as you see, I put on my right side a question mark. What decided about BCT? BCT, as you know, is a more complex parameter, so it's more parameters, more aspects which decided about a BCT. Shortly also to completing a burst of a corrugated board, the same equipment like for a paper, only different pressure is used, yeah, because a corrugated board is a stronger material, so we have to use a higher pressure to burst the corrugated board. And the FCT flat crash test, it's, yeah, depends how strong is the fluting, so it's correspond somehow with the CMT or with the S test, which I was also trying to describe, to explain to you. Okay, so in case of paper parameters and impact of paper parameters to corrugated board, quite often people are saying SCT, ECT, BCT. Give me a very stiff paper with a high compression, with a high level of short compression test. That will give me a strong corrugated board, high ECT, and finally BCT. It's a very simple, let's say, performance packaging way, which I don't like, which is not a complete definition of performance packaging. First of all, let's consider that ECT test is based on a very small piece of corrugated board, which is just 25 centimeter square, 10 centimeter length, 2.5 centimeter high. So it's only small piece of board, which does not give a full picture of performance packaging and strength of final box performance. So it have to be, wants to make a really good prediction or estimation of a packaging, we have to consider a bottom line on that slide and top side of the slide. It means the compression. On the bottom, you have, again, SCT, ECT, and finally BCT, which is a directly compression, static stiffness. On the top, we have a tensile stiffness of paper and bending stiffness of corrugated board machine cross direction. That two parameters are telling us about dynamic parameters, not only about the compression. And nowadays, it's already years. We are going every year down with the grammage, so you are going, trying to keep a proper performance in a proper price, which is coming like a pressure from your customer. So lightweighting is never-ending story, but going down with the grammage, taking a paper with a lower thickness, that is an effect which is so-called buckling effect, weakening of a paper, yeah, because of a low thickness. That aspect is also coming or have to be considered, wanted to make a proper paper selection, proper prediction in aim to get what we wanted to go, what we wanted to get, sorry. It means expected BCT of a box. Yeah, overview of a container board grades, just, you know, it virgin, recycled, and the hybrid. Jacek was describing what Mondi is producing, what we are producing like a container board producer. This general classification is just virgin, means fully virgin or predominantly virgin on the left side. Recycled means fully recycled or predominantly recycled. And inside we have a hybrid, which is a mix of a virgin fibers and recycled, white, brown versions, of course, in all grades. Mondi is, by the way, a leading producer of hybrid papers, considering both version brown and the white. Nowadays, quite often, or very often, during different presentations, the speakers are touching circular economy, the closed loop, how it should looks like just now in case of trend related to sustainability. So looking on that product cycle, in case of our business, what you see on the right side, yeah, paper production, corrugated board, boxes, putting goods, distributing, selling goods with the boxes, after that recycling, and again, and again, and again. There's a lot of prediction calculation proving that without the virgin fibers, that is impossible to produce paper. It have to be, as you see here, 20 to 30% virgin fibers added to the cycle to be able to produce paper. If somebody will say, let's stop with the virgin fiber, let's produce only based on recycled, estimation prediction is saying within 6 to 18 months, will be lack of material for a paper and corrugated board production, which is quite simple to explain. Yeah, even if recycled fibers are going on in the cycles a few dozen times, based on a different study, it can go on 25, 35, 40 times in the cycle. Yeah, but all is not endless fibers. And this virgin is needed. And of course, considering recycling level, which is maximally 80%, so 20% of material is lost during every cycle, plus producing recycled paper is another 18-20% reject, yeah, all kind of impurities, printing, etc. So another 20 is lost. So altogether, from a 100% or let's say 100 tons of paper which we put on a market, getting back after first cycle is around 64 tons, and that is repeating. Yeah, so it had to be addition of a virgin fibers to the cycle wants to keep our business going on. 30% is a perfect, considering what you see on the left side. Our hybrid papers, we produce like among the white version, which we call Smart White, and the brown, which we call ProVantage Craft Top Liner X. It's around 30% of virgin fibers on the top and 70% of recycled on the bottom, so predominantly recycled. The most sustainable product, let's say, if I can describe that like that. Yeah, example, that for me, that was a very interesting study exercise, which I did already some years ago. Wanted to get a difference between virgin and recycled. As you know, or most of you, or all of you know, it's more and more, already several years, or more than 20 years, a lot of recycled, fully recycled papers, which are so-called high performance paper, which have a lot of starch on the surface, or another chemicals, or another polymers to make these recycled papers very stiff. Yeah, giving a very high level of a compression. So I did exercise. As you see, two kind of corrugated board. I mean, the same kind of board. That was a B-flute. The same grammages, 2 times 160 liners and 135 recycled fluting. On the left side, composition is based on a high performance liners. And on the right side, you see also 2 times 160, but a craft top. So hybrid papers with a 30% of virgin fibers in it, and the same fluting, 135 grams. And of course, we produce a corrugated board and did the boxes, and we checked ECT, bending, burst, and also BCT on a classic American box. What you see in a table in a red ring, you see minus 30.5% ECT. ECT, that is a comparison of a kraft top, yeah, to recycled. So this recycled high performance composition notice a higher ECT. ECT was higher by 13.5%. But considering a dynamic, not a static stiffness, static stiffness ECT up to 14% stronger for fully recycled. But considering partly virgin papers, the bending stiffness, geometric bending stiffness was 20% higher than recycled, and the burst was plus 34% higher than fully recycled HP. Yeah, so that is proof, or that give me a proof that okay, that is only static stiffness compression, much higher ECT, but considering a dynamic, a bending stiffness, and a burst, that is a plus of hybrid papers with some virgin fibers content. BCT test, also we did a BCT test, and that was in opposite. In this case, ECT, as you remember, was lower for partly for hybrid paper, but in case of BCT, where we are putting a box under a press and pushing that down, so it's dynamic coming, yeah, the elongation, the tension. So that was not so much, but that was a significant difference, that the BCT was higher on the hybrid papers, and also this deformation way was slightly longer, which is clear, virgin fibers are more elastic than fully recycled. So all in all, summary, what means performance packaging? It means correlation of parameters and how strong is the corrugated board and the boxes. So it's not only SCT to ECT, but it's also dynamic parameters should be considered, tensile stiffness of paper, and bending, geometric bending stiffness of corrugated board. And of course, important is also something what I put in the middle, not only parameters, fantastic parameters, but also perfect board production on a corrugator. It means a corrugated board without any defects like blisters or washboarding, which not keeping a flat surface, and not flat surface, also creating, deciding about the level of parameters. So all in all, the performance packaging is a bit complex, cannot be treated only based on SCT or only on tensile. It's always have to be more in balance, and more aspects have to be taken under consideration. On that slide, on that graph, maybe some of you have seen somewhere, if some of you have seen my presentation, I am saying that that slide, that graph, is showing everything or telling everything about the performance packaging on one graph. Yeah, on a graph you see a level of ECT and bending stiffness of a one corrugated board, which you see here, which is quite light recycled papers, 2 times 120 and fluting 100. It is the same papers, the same grammages, only E, B, and C flute. And that is based on hundreds of test measurements, because the results are coming from one of my customer. It means it's a long-term measurements. So in case of ECT, which I am always saying static stiffness compression, the E flute is the strongest, which is clear because E flute is a 300 flutes per linear meter. So many bonding by starch make it very stiff. And going higher with the flute BC, this ECT is a slightly lower, not so much, but slightly lower. Completely opposite situation is with the dynamic, means bending stiffness of corrugated board. That is a completely opposite. and the differences are much higher. The lowest bending, the lowest dynamic is represented by E flute. And the highest dynamic is on a C flute, because about the bending stiffness, the distance between tops of a flute decided. So higher, longer distance, higher bending, yeah, higher elasticity. So all in all, in case of performance packaging, as long as we are considering, let's say, a small dimensions of a box, which I put on the bottom, let's say up to 15 centimeters, 15, 20 centimeters high, 20 centimeters length width. When it's a small box, everything depends of a compression. So our prediction can be based only on ECT, but with a slightly higher or bigger boxes, going up with the size, that dynamic is coming, and that we have to consider both ECT and BCT. So that is somehow a summary, I would say, of the first part of the presentation, correlation between paper parameters and strength of corrugated board and the boxes. So just now, second part, related to parameters versus runnability. Yeah, I will try somehow to describe parameters in a runnability contest. Yeah, runnability cannot be measured in laboratory. Really? No, maybe it can. It can. It means knowing level of few or several parameters, we can easily say about runnability of a paper grade in aim of end-use application. So considering runnability, what is important? Equal moisture, that we know, equal moisture and substance without variations across, and in machine direction, thickness also, no variations across, sizing of a paper, porosity, air permeability, strong bond of paper. Most of liners, or let's say 99% of liners, it's a 2 or 3 layers papers, and important is to have a good internal bonding between a layer's top and the bottom, so Scott bonds the tensile, and also more parameters like TSO, tensile stiffness orientation, tensile stiffness, machine direction, tensile index, cross direction, the ratio between machine direction to cross direction, etc. That everything is possible to check, to measure, and that is telling us more about runnability of different papers. And knowing more, yeah, we are taking back to a starting point, a sentence of Michelangelo Buonarroti, knowing more, our prediction is better, we are more perfect. Nowadays, in a paper laboratory, which is also slowly coming on a corrugated side, we have a testing machine, which is so-called autoline. A few or several, depends how much money you want to spend, few or several instruments under one cover. Paper is going through, paper is tested. It's automatic data transfer to the system. Parameters like burst, TSO, SCT, tensile stiffness, everything is measured. Yeah, it can be physical and ultrasonic, so destructive, non-destructive checks. But all at all, there are several parameters which is possible to check, and those parameters are telling us about the runnability. That was already told. The profiles, moisture, substance, thickness profiles should be as much as possible flat. Yeah, the profiles should not be smiling shape or set shape. If, as I put it on the bottom, it is better for a profile if they are a bit more set, going like down, like a down warping, not like a smiling, like a up warping. Yeah, that is always a bit better when its shape is a bit set, not smiling. Also, moisture machine direction, because quite often we are considering only important are profiles across. No, also moisture in machine direction, unwinding, converting a reel on a corrugator. Yeah, if a profiles are okay, but moisture in machine direction is representing different level. Let's say starting to unwind a reel is a 10%, and on the end of a reel is 6%. That's a huge difference. So that will be completely different warping, starting and ending with one reel. So this moisture profile with a maximum variation plus minus 0.5 means that the moisture profile should be in a range within 1% across, the same related to machine direction. Also in machine direction, moisture variations should be not higher than plus minus 0.5. Also should be within 1%, not more. In case of proper runnability, it means to get a flat corrugated board on an end. Yeah, what do we know from the TSO profile? Maybe some of you are already close to that, tensile stiffness orientation profile, which is just a result itself, is telling us is telling us or showing angle, the positioning of the fibers across a paper reel. Yeah, the fibers in a perfect paper, the fibers should be put in machine direction or in cross direction, but it's never like that. Always some fibers are putting on a wire and later on a paper, positioning a bit left or a bit right, which is expressed in an angle. So TSO is telling us an angle, +4, +5, or +10, -7, etc. And if this TSO angle is too high, side to side, if it's higher than ±5 degrees, that is creating quite often the twisting warp of a corrugated board, a kind of warp which you see on a photo on the right side of a board. Yeah. TSO, and so far you cannot find TSO, or it happens sometimes. Some producers are indicating a TSO level into technical data sheet, but it's really good. It's really good to know, because that very well indicating what we can expect in case of flatness. Knowing precisely TSO from every reel, you are able somehow also to make some corrections. I mean, if you have a reels with a minus angle, and if you will put that reel on a single phaser and wants to compensate plus TSO plus angle, you will put on a double backer, the paper will compensate each other. I put it here a bit like a mathematic calculation. If you will take two reels like liners, outside, inside liners, with the minus TSO, it's like a -4 plus -4, you will get -8. So you will intensify the twisting warping. But if you know precisely, you can put 1 plus, 1 minus. Example like a -4 plus 4 is 0. So one reel will compensate to another one and will give more flat or flat corrugated board. So more information give us more solutions. Tensile stiffness index or tensile stiffness machine direction profile. It's indicating us if a paper reels, if a variation of TSI MD are too high, that can tell us that can be a problem with a flop, with a loose edge from one side. So in this case, the TSC MD profile variation should be not higher than 5 to 10%. That it's telling us that's we have a chance not to notice any slack or soft edges. The same with the TSC cross direction. In this case, recommendation is that the variations should be not higher than 10 to 20%. Tensile stiffness generally, as I was already mentioned to you, very complex parameter in case of prediction of strength of corrugated board, but also in case of runnability. Most of the cases, it's a non-destructive parameter. It's just based on an ultrasonic 8 pairs of sender and receiver going through a paper around and giving us level of TSI CD, TSI machine direction, cross, etc. Also the ratio. I was mentioned to you that important is, or relatively important to know tensile stiffness machine to cross direction ratio, MD to CD. Why? Because as you maybe know, paper itself may have higher or lower tendency for warping, up or down. And what's to know which paper has higher tendency for warping, which paper has a lower tendency for warping up or down? That this MD to CD ratio, tensile stiffness index MD to CD, this can be also SCT ratio MD to CD, yeah, is indicating you which paper is, let's say, a bit better in case of warping. And that lower, what that means, lower ratio, more flat corrugated board produced based on such paper. Lower ratio is better for runnability. So all at all, TSO wants to avoid a twisting warp. Maximum variation should be plus minus 5 degrees, not more. When it's over plus minus 5 degrees, that can indicate you, okay, a reason of a twisting warp is a paper. TSC cross direction variation not higher than 20%, and tensile stiffness index profile machine direction, I was mentioned that not higher than 10%. That is a guidelines for a best performance. Sizing of paper, yeah, quite often or a lot of corrugated board producer is thinking, yeah, sizing is important. We know how much paper is absorbing glue during production on a corrugator, or how fast is absorbing ink. Sorry to say, but I have the same opinion already more than 20 years. In case of COP 60 or COP 120 is completely useless parameter. Yeah, it's a parameter which is not really telling us something in case of glueability on a corrugator or printing on a printer. Why? I was trying to express that on a graph on the bottom left side. You see two lines, red and the gray. It's a two kind of papers which have been tested in case of COP 60 seconds. Yeah. And in this test, I wanted to show that, as you see on the end, both papers, red and the gray, have the same level of COP 60, 35 grams. But if you will consider absorption of water during the 60 seconds, both papers had completely different behavior. This gray paper, the paper, let's say this one, was absorbing much less, like a starting point, going up later on with the absorption. The second paper was absorbing quite fast and a lot during the first second, later on slow down. So the COP 60 is giving us information how much water paper is absorbing after 60 seconds. Do you need the information how much paper is absorbing water after 60 seconds when glueability on a corrugator is going within a second and the printing is sometimes going within a millisecond? We need, in case of a printing or glueability, we need the information what is paper characteristic in case of absorption of glue ink in the first millisecond or first second. So nowadays, another parameters like contact angle, or one which I like the most, PDA, penetration dynamic analysis, are telling us perfectly what is the absorption of a liquid, a glue or a ink during first 2, 3, 4 seconds. And this information is a most efficient, let's say, considering our processes. So the future more PDA will be than COP60, which is, once again, in my opinion, is completely useless. Very simple drop test, which you most probably know. Quite good always. That is quite good to express quickly. Yeah, what are the differences between the papers? Putting just a drop of water on a paper surface and measuring time when this water will be absorbed, eaten by a paper, when this water mirror disappeared from a paper surface. That is seconds, few dozens, and that it's still quite good. Paper delamination, yeah, which also from time to time is creating a problem. As I was mentioned, every liner is a 2-3 layer structure, so it's important that the internal bonding between the top and the bottom is quite strong. One of the parameters, the best one I would say, is a Scott bond, which is in joule per square meter, telling us how strong is the internal bonding between top and the bottom. Yeah, cello tape, 2 pieces of paper, pendulum is just touching a sample of paper, making a break between the layers, and the force which is needed to break this internal bonding is a level of Scott bond expressed in joule per square meter. Much faster and relatively good also is something what is called ZD tensile. Yeah, it's a bit different story. You may have a look on animation on bottom right side, because during a Scott bond, that is the pendulum is going from one side touching the paper. In this case, it's a Z direction. Yeah, you see just now, piece of paper is going into the machine. The cello tape is applied from both sides. The 2 cylinders, top and the bottom, are getting closer each other, touching a paper. It means sticking to a cello tape. And when test started, cylinders are going in opposite direction, as you see on the photo in the middle of the slide. And the force, a pressure, which is needed to break internal bonding, is a level of ZD tensile, and telling us how is it good or not, or too weak, may create or not create a problem. In case of the lamination, important is also to know, yeah, what kind of raw material was used for a paper. You know, we are using softwood, hardwood, means longer fibers, shorter fibers. Good to know, because yeah, with the shorter fibers, it's a bit more difficult to get a proper bonding. It's easier with the softwood. We have also have in mind always what kind of paper it is. Is it fully virgin white top kraft liner, or fully virgin or predominantly virgin brown kraft liner, or is it kraft top? Kraft top hybrid paper is a good example, because it's a combination of virgin and recycled, which is quite difficult to get a proper a strong internal bonding, which is always a challenge. So converting such paper, we should also have in mind let's maybe treat this paper a bit more delicate than fully virgin, because of the impact of a temperature and glue absorption is creating a weakening of this internal bonding. So good to know, is it fully virgin, predominantly recycled, fully recycled, etc., because that has an impact. Yeah, and impact that on that slide I wanted to express, that is also impact of a converting on a corrugator, the impact of temperature and the glue absorption. Yeah, temperature, as getting back to a different kind of papers on that slide, different raw material, shorter, longer fibers. When temperature is going up, the layers are shrinking differently. Yeah, the softwood is shrinking more than hardwood, or virgin fibers generally are shrinking more than recycled. That created a tension between the layers and creating a weakening of an internal bonding, which may create a delamination of ready corrugated sheets. This kind of delamination, which is so-called a cigar or a local delamination, mostly appearing on a heavy-duty corrugated board with higher substances, so can be sometimes the settings on a machine, the settings on a feeder, but also not good, not high enough internal bonding between two layers. Sometimes on a paper machine, paper is produced already not fully properly, I would say, and that also, I mean, I don't know, is it good to know? For me, it's good to know, like a paper maker, that we have a different kind of paper machines, different kind of wire section, because internal bonding is created on a wire section where wet layers are bonded each other. So we have a for linear standard top wire, we have more and more paper machine based on a gap former. So those things have an impact also how strong is internal bonding. The most weakest papers in case of internal bonding or weakest that the delamination is appearing quite often is a white top test line. So fully recycled, very degraded fibers, because the bleaching process is also involved. And quite often white top test liner is a 3 layers papers or even 4. So internal bonding is not so high. Scott bond is much often below 200 grams. So it's good to know that this paper is the weakest in case of risk of delamination. Garley, yeah, I have to speed up, I suppose, a bit. Porosity of paper, mostly Garley. I mean, most popular is a Garley, is also Benson, but most popular is a Garley. Yes, it's also important in case of runnability, knowing if paper is more or less open. Yeah, very simple methodology telling us how much air. No, Garley is telling us just directly how much second it will take 100 milliliters of air going through described area. It's just a cylinder which is pressing air through the paper. Yeah, shorter time, less seconds, more open paper. Yeah, a longer time, more seconds, paper is more closed, density is higher. Just I put here as an example what most probably some of you working on a corrugator, on a single phaser, have seen quite often. This kind of strip on a formed fluting that also quite often correlate with porosity. Nowadays, is a lot of paper which is treated, included fluting, which has a lot of starch on a surfaces. It means paper is very close. When it's coming to into a corrugating roll, where a form fluting is keeping on a corry rolls by overpressure or by vacuum, yeah, when paper is very close, it's creating a high pressure or high vacuum level, and paper is pressed into slots on a corrugating rolls. That's what you see on the photos. As you see, it's a lot of things written on the slides, and I believe the presentation will be shared with you after a webinar, so some you can read a bit more if you would like. Smoothness of paper expressed by Benson methodology, yeah, is saying as of course paper is more or less smooth, more rough, less rough, more or less unevenness, yeah, on the bottom. The Benson, the smoothness is expressed in milliliters per minute. Less milliliters, it means more smooth paper. More milliliters, more rough. As you see, more rough, it means more unevenness, more air is going out. So less is higher smoothness. And also is important in case of runnability. I will give you just a simple example. A smooth paper and a rough paper. Smooth paper has a better contact with the surface of preheaters, with the surface of hot plates. So transfer of heat, it's much faster to the corrugated sheets, which have a paper with a very high smoothness. More rough paper, more unevenness, it means lower contact area with the heating plates. So it's also good to know, more smooth paper, that is faster heat transfer. Let's keep a bit lower temperature if possible, or in opposite, that is very rough, 3000 milliliters per minute. No, we have to give a bit higher temperature. DST, dynamic stiffness test, which is called also quite often Chalmers test or torsion test. It's something new, which is on the market relatively short comparing to other parameters. Yeah, it's just a torsion, putting a piece of corrugated board. Yeah, you will see that on a video. Some of you most probably know it. And following, let's say, a description given by a producer, that the twisting, because it's just a twisting, one left, right, left, right, left, right. It seems to be a good parameter, and the producers have been mentioned, yeah, it's a good correlation between BCT, FCT. I would say you like that. We did, one of my customer in Europe did a really long study based on this methodology, based on that instrument, yeah. And all at all, it's relatively good methodology, which is describing a corrugating and a box process in case of printing, crushing, pressing. Yeah, it's a good parameter, good methodology for higher grammages, for mid or higher grammages, for heavy duty, for kraftliner, semi-chem, yes, but it's completely not precise for a lightweight recycles. For a lightweight recycles, for a low grammage recycled corrugated board, the variation of results have to be up to 20%. So that was impossible to get any proper conclusion, I would say. So all at all, again, it's a good distortion. Dynamic stiffness tester is good to describe how corrugated board and boxes have been produced in case of crushing for a higher grammages, for a stiffer papers, not for a lightweight. That is a summary. Parameters versus runnability. Sometimes not everything we can measure. Sometimes something have to be checked in an organoleptic way. Paper formation. Yeah, it's very simple story. It can be better or worse. It means more even or uneven, and very uneven cloudy formation with some branches of fibers. And most of the cases we are looking on a paper under a light, under light, saying, very good or not so good formation. When it's really very bad formation, in case of liners, a glue can be absorbed not very evenly across, creating some leakage point, yeah, or some blister. If not leakage points, can create faster blisters on the surface of corrugated board, as you see on the photo. In case of, for example, semi-chem fluting, you see here very terrible formation when this fluting is coming between a corrugating rolls, especially semi-chem, can start to crack on a top. Surface finishing, considering this best practices or something what we cannot really measure. But in case of a surface finishing or surface cleanness, we can simply say, like a summary, that all surface defects visible by naked eye disqualifies the paper. That's all. Yeah. If something is on the paper, impurities, dirties, or whatever, that disqualify a paper like a good quality paper. There are a few words on the end or a real finishing, which is also operation going on after outside, after paper machine on a rewinder. So that also a lot depends during that process still from operators, yeah, to get very well winded reels with even tension in case of core, in case of paper breaks, when it is a paper breaks that have to be properly bonded, glued together to avoid later on problem on a corrugator. In case of parameters and runnability, coming to the really final summary, it's I would propose to you just some very simple exercise, which I did few times with some of my customers in Europe. There's some estimation or how to get a runnability, how to say this is good runnability paper, that is not good runnability, it's not good paper in case of runnability. That I did the exercise, as you see, checking a parameters, TSO profile. Always, all of you has 3, 4, 5 or more paper suppliers. So let's take a samples of all of them in some paper grades, and let's check TSO, check profiles, sizing, even in case of COP, SCT, burst, TSI, if possible, ratio, SCT or TSI, MD to CD, this ratio which has influence on a warping, up or down warping, plus a simple rating by operators. It's good to make a simple sondage across operators on a corrugator, what they think about, what you think about Kraftliner Mondi, Krafttop Mondi, or Smurfit Kappa, Westrock, or Klabin, or whatever, just to make some scale from 1 to 5, and to put also into that table. So you see one of example, several suppliers, parameters, and opinion of operators. Give an answer supplier 9 and 10 seems to be the best in case of parameters and runnability. So maybe it's good from time to time to make this evaluation to be able to say that seems to be the best paper in case of strength and in case of runnability. That just in a graphic form, the factors affecting runnability and effectiveness, of course, of converting machines. Once again, I put on the bottom a few groups: real finishing, sizing, surface finishing, formation, profile, and pluses and minuses. What has a positive and negative impact on efficiency on corrugator. Last two slides. Coming to the end, so container board and corrugating process of today. And this slide is coming from a different presentation about the future, but I find it useful for that presentation also. I would say still nowadays it's a wall. I put a photo of a Chinese wall. It's a kind of wall between paper producer, it means us, and you like a corrugator and box producer. What that means? That means that we are, in our case, we are measuring much more, and we are giving to you like a data sheet only part of the parameters which we are measuring on every jumbo reel, on every production order. So we are not passing everything. Not only we. I'm saying that the wall is generally between the paper makers and corrugated board producers, and the future will bring a change. So corrugating process of the future, quite simple to say, also slide from a different presentation. First of all, we will pass more informations to you inside a paper reel based on some sensors. Nowadays, sensors started to be relatively cheap, so we can pass much more, not only burst, SCT, and grammage and sizing, but also TSI, TSO, all kind of measurements we are doing. And that also on the way, paper reels are the sensor is monitoring two parameters, moisture and humidity. After that, when a reel is coming to the corrugator, let's say a new corrugator is just reading all these parameters and is creating a proper settings or giving operators information about the reel in case of the several parameters, which let operators to make a better settings, which final result will be a perfect board. So sorry that got me a bit longer than 1 hour, but not so much considering introduction of my group. So thank you very much.